This is System Software and Compiler Lab exercise number 10. In this experiment, we are going to see intermediate code generation. So as you can see in this exercise, our main aim is to convert the given arithmetic expression to 3 address codes. So the compilation process can be divided into a number of subtasks called phases and intermediate code generation. It is one of the phase of the compiler. Once the syntactic constructs are determined, the compiler can generate object code for each construct. But the compiler creates an intermediate form. It helps in code optimization and also to make a clear-cut separation between machine-independent phase, that is lexical and syntax, and machine-dependent phase, that is optimization and code generation. One form of intermediate code is a parse tree. A parse tree may contain variables as the terminal nodes. A binary operator will be having a left and right branch for operand 1 and operand 2. Another form of intermediate code is a 3-address code. It has got a general structure of A is equal to B, operand C, where A, B, C can be names, constants, temporary names, etc. and OP can be in any operator. Postfix notations is yet another form of intermediate code. So initially this is how the algorithm goes like. We need to get the expression as an input, scan the statements from left to right, then frame new statements such that it can perform one operation at a time, either assignment or arithmetic or relational operations, then display the new set of statements. So now let's see how the code exactly looks like for this intermediate code generation. As you can see, the code is being given here. This is how the program looks like. I have declared the header file, that is stdio.h and then string.h, as well as I have also declared some integer variables and then a character variables, and also I have got functions that are being declared which also contains parameters. I have declared a structure here which is called exp, and inside the structure I have a few variables, and then the structure object, that is k, is a structure object, and I have given 15 as the size of the array. So in the void main, I'm simply going to take the expression from the user, and then I'm going to call all these following functions. Now let's see what exactly these functions are all made up of. So as you can see, yes, the first one is find OPR, that is find. Yeah, so as you can see, I have used many number of for loops. That is, if I is equal to 0 and str, that is string of I is not equal to 0, then I plus plus. Then the string of I will be equal to semicolon, and then the k of j dot position equal to I. The values will be reallocated, as you can see here. The same thing happens in all the for loops, but then just the values will keep changing, because according to the operand, that is semicolon, hash, star, plus, minus. So according to this, the values will keep changing, that is what function it does will keep changing. So the next one is explore. The next function is explore. So here I have initialized I value, and then I have opened a while loop where the condition is k of I dot op is not equal to 0. So f of left, this is another function where f of left, as we already saw, it clearly says that the operation happens from left to right. So f of left is given to that function. You're going to pass the values k of I dot pos, that is position, and to right we are going to give k of I position, that is same positions. Then in your string, that is str k of I dot position, we actually decrement the temporary character. Then we are going to display what exactly, that is the intermediate code, that is say if it is a plus b into c, then it will be c into b will be assigned to a separate character, and then it will be added to a. So that is what happens here in this explore function, and then that is what continues. Then yeah, we have also declared the f left function, and we have it contains a parameter, as I said. And here also using a while loop, a series of conditions are being checked, if it is plus symbol, or if it is less than 1, or if it is containing any minus symbol, or if it is equal to or minus or hash or semicolon. Then accordingly the left variable will get incremented, or it will stay the same way, or the string will get different values, that is dollar, or the flag will be set. Then we have f right also, the same thing, almost the same thing happens here, but then from the right side of the string this starts happening. So now let's see what the output will look like. So let's compile this program. So when we compile this program, yeah, it got compiled. Now let's run this program. /a.out. So yes, now let's enter an expression, a simple one. Say a plus b star c, and then maybe I'll put something in bracket, say e divided by f. So now let's see what exactly the intermediate code generation is. So as you can see here, first preference go to the bracket. So as you can see, e divided by f, the first preference goes to our multiplication. So b star c will be first considered. So that will be given to the z value, and then the next preference goes to the division. So what happens, that is a will be kept as such, and then z, that is a plus z will be given to our y, and then e divided by f is again inside a bracket, so that is given another separate preference. So that will be considered as your as a whole, and then the value in y, that is a plus z, will be again given to the value of this the value that is contained inside this bracket. So this is how the output looks like. Maybe we'll try another one. As you can see, enter the expression. Let's say a plus b divided by c, then in bracket plus, in bracket let's give e star f. So now let's see how the intermediate code looks like. So here, as you can see, as I told you, initially multiplication is given the first priority, so e star f is being done, and also it is inside the bracket. So z is equal to e star f, that is this, and then later on, as you can see, then the next value, that is a plus b, is being considered. So that value is given to y. So y divided by c plus of this z. Then what happens is, this again x is equal to c plus and whatever is given inside the bracket. So the code is being changed as y divided by x and x into z. So this is how the intermediate code generation will take place, and this is the end of the program.